Every time you flip a switch, you're plugging into this massive, planetary scale machine. But what's really powering it? Well, in this explainer, we're going to go right back to the source. It seems like such a simple question, right? But the answer, well, it's this incredibly complex web of science, economics, and even history. So let's peel back those layers together and see where our power truly originates. And here's the real kicker, the core of this whole thing. There's just no such thing as free energy. I mean, every single source we use, I don't care if it's wind or coal, it comes with a trade-off. It's this constant, delicate balancing act between power, price, and, of course, the impact on our planet.
Okay, so let's start with the absolute giants, the fuels that basically built the modern world. They're called conventional for a very good reason, and they present us with a really deep dilemma.
Yeah, we call them conventional because, think about it, we've spent more than a century building the entire world's infrastructure around them. We're talking pipelines, power plants, the whole shebang. That system creates this incredibly powerful lock-in effect. And for the last 200 years, one type of fuel has just completely dominated that system. It built our industries, it shaped our economies. We're talking, of course, about fossil fuels. So let's talk about the reign of these heavyweight champions, petroleum, coal, and natural gas. They're basically ancient stored sunlight. I know, that sounds a little weird, so let's break down what that really means. Okay, so what are fossil fuels? The best way to think about them is like solar batteries that have been charging for millions and millions of years. You have all this buried organic matter, plants, animals, and under incredible heat and pressure, it turns into this super energy-dense fuel. But here's the catch, and it's a big one. This process, it's not something we can repeat on a human timescale. When they're gone, they are gone for good. But, crude oil straight out of the ground isn't all that useful. The real magic happens in the refinery using a process called fractional distillation. It sounds complicated, but the idea is pretty simple. You heat the oil up, and that lets us separate it by molecular weight. We can sort the tiny, light molecules from the big, heavy ones, and that's how we create all these different products. And this table here shows you the result. That molecular sorting is just incredibly precise. You see the shortest carbon chains? Those become gasoline for our cars. The longest, heaviest ones? They end up as the asphalt on our roads. It's amazing, really. Every single part of the barrel has a purpose. But of course, all that incredible energy density comes at a very steep price. You've got the risks of extraction, like devastating oil spills. You've got the carbon dioxide and other pollutants released when we burn them. The truth is, the environmental costs are felt at every single stage of the fossil fuel life cycle. So this all leads to a pretty natural question. If our main energy source has such serious drawbacks, what are the alternatives? Well, one of the most powerful and definitely one of the most controversial is nuclear energy. And nuclear power, well, it really is a true paradox. It's fascinating. It solves some of the biggest problems we have with fossil fuels, but in doing that, it introduces a whole new set of really, really difficult challenges. And this right here is the core conflict. I mean, look at this. On one side, you get an immense amount of carbon-free power from a tiny little bit of fuel, but on the other side, you get this highly radioactive waste that we have no permanent home for, plus the small but absolutely catastrophic risk of a meltdown. It is the very definition of a high-stakes trade-off. So you can see the dilemma we're in, right? Fossil fuels are polluting, and we know they're going to run out. Nuclear power is clean, but it comes with these huge risks and this major waste problem. So naturally, this has sent scientists and engineers on a massive hunt for other alternatives. And that hunt has led to a few key challengers stepping into the ring. We're talking about things like creating synthetic liquid fuels from stuff like coal, or trying to harness hydrogen, the most abundant element in the universe, and even, believe it or not, growing our fuel with modern biofuels. All right, let's just focus on hydrogen for a second because its promise is, well, it's almost magical. When you burn hydrogen gas, it combines with oxygen right from the air, and the only thing that comes out is water. That's it. No carbon dioxide, no soot, no acid rain, just H2O. I mean, it sounds like the perfect fuel, doesn't it? But the laws of physics are very, very strict. And here's the catch. It takes at least as much energy to create hydrogen fuel in the first place as you get back when you burn it. You see this number? It's a perfect balance. So that makes hydrogen an energy carrier, kind of like a battery, not an energy source. And until we can figure out how to produce it with cheap, clean electricity, it's just not really economical. Now, biofuels, like making ethanol from corn, they present a whole different kind of trade-off. On the one hand, yeah, they're renewable, which is great. But on the other, they compete directly with food crops for land. This creates a really tough fuel versus food debate, pitting our gas tanks against our dinner plates, and that can have very real impacts on global food prices. Okay, so far we've been looking for a new source, right? Some kind of magic bullet that can replace everything we have now. But maybe we're asking the completely wrong question. What if a huge part of the solution isn't about making more energy at all, but about wasting less of it?
And that brings us to our final and maybe the most overlooked piece of this whole energy puzzle, efficiency. Now, I know it's not as flashy or exciting as some futuristic new fuel, but it might just be every bit as important.
So, to put it really simply, energy efficiency is just the ratio of the useful work you get out compared to the total energy you put in. Any energy that doesn't become, say, light from a light bulb or motion from a motor is just lost. And usually, it's lost as waste heat. And this chart, wow, this shows just how much we're actually wasting. Take a look at our main electricity sources, fossil fuels and nuclear. They lose almost 2/3 of their potential energy as heat before that power even reaches your outlet. I mean, think about that. The potential for improvement right there is just enormous. And that's exactly why conservation is such a powerful energy source all on its own. Improving the efficiency of a power plant, or even just you switching to a modern, energy-efficient refrigerator at home, it doesn't just save you money. It directly, actively reduces the total amount of fuel we have to burn in the first place. So, this leaves us with one final big question to think about. Is the future of energy really about finding some perfect brand new fuel? Or is it about a new mindset? A fundamental shift towards just being smarter, more efficient, and more deliberate about the power we all use every single day. Thanks for joining us on The Explainer.